We can think of the vector 2bc as a set of instructions for moving from point B to point C, and then that set of instructions multiplied by 2. So first, we want to start out by just figuring out what is the set of instructions we need to get from B to C. And we can do that by labeling the points B x1 and y1, and C x2 and y2, and then subtracting the x and the y coordinates. And that will tell us how far we have to move in the x direction and how far we have to move in the y direction to get from B to C. So if we plug that information in, we'll have 5 minus 3, and then 0 minus 4. And if we work that out, we'll have our vector BC, which is going to be 2, negative 4. Now we need to take that set of instructions and we need to multiply it by 2, which means we're going to take each of those components that we have from BC, our 2 and our negative 4, we're going to multiply them by the 2. And so this is going to give us our final component form for 2BC, which is 4, negative 8. Now if we need to find the magnitude of that vector, that's really asking us to find the length. So we treat these two components as legs on a right triangle, and we can find the magnitude by solving using the distance formula. So we can say that the magnitude of 2BC is going to be equal to the square root of 4 squared plus negative 8 squared, which will give us 16 plus 64, or the square root of 80. And we can simplify the square root by finding the prime factors of 80. So 80 will break down into 4 times 4 times 5, which allows us to pull out a 4 and to get our final answer that the magnitude of vector 2BC is 4 times the square root of 5.